Alright, welcome to the Vector Podcast, and we're going to show you how vectors are added together and combined into making a resultant. Resultant being what happens when you have two vectors. So let's look at what a vector is. A vector diagram shows the direction and the relative magnitude of a vector quantity by an arrow. And as you can see, those are vector arrows. They're for a little car moving to the right-hand direction. Now, the size of the arrow is very important. That tells you how much velocity there is in this case, the V standing for velocity. So the ones on the top are all constant velocity, so all their arrows are the same length. The ones on the bottom, the arrows are getting bigger and bigger as the car moves to the right hand side, and as this gentleman is saying here, they are accelerating. So the two important things from this is the size of the vector. It tells us the amount of velocity we have in this case, and also the arrowhead shows us the direction. So what is the difference between the scalar and the vector? Well, scalar is a word you may not have heard before, but it is a quantity that's just magnitude alone. And vectors are quantities with both a magnitude and a direction. So a great example of that is distance and displacement. You may not be familiar with the word displacement, but a distance is a scalar quantity. It's how much ground an object has covered. Now here's the difference. A displacement is a vector quantity which shows you how far it's out of place. It's the object's change in position. It's not just the distance covered, it's also in what direction it's covered. So for instance, we can say I drove 250 miles. That would be the distance I drove. But I drove 250 miles northeast. That would be displacement. So there are two ways of solving vectors. One is the graphical method, and the other one's the analytical method. Here's a picture of the graphical method. Basically, you're drawing out the vectors. You're adding your two vectors. You draw them out, tail to the head of the vector, and then you draw your resultant. With an analytical way of solving a vector, we use the Pythagorean theorem, and where a and b are equal to the number values of the two vectors. So we have 11 kilometers for both these vectors. They happen to be the same. We square both of them because Pythagorean theorem is c squared equals a squared plus b squared. And if you multiply 11, if you square 11, and then, which is 121, and add that result to 11 squared, which is also 121, you're going to end up with 242 kilometers squared. And if you take the square root of that result, you'll end up with 15.6 kilometers. Let's look at an example vector problem. Let's say we have a motorboat that's heading due east at 6 meters per second across a river that flows due north at 9 meters per second. What is the resultant velocity of the boat? And if the river is 136 meters wide, how long does it take the motorboat to reach the other side? Alright, let's see if I can do this. Very good. So, what did I have here? I had a river flowing, motorboat heading west at 16 meters per second. I'm sorry, east. So there's my 16 meters per second, and it's going across a river that's flowing at the river's flowing at 9 meters per second, in the northern direction. So where's my resultant? Well, my resultant is going to be, if we draw dotted lines, those, this dotted line right here is going to be equal to 9 meters per second, and this dotted line up here is going to be 16 meters per second, and my resultant is going to be right there. Now the question is, what is the magnitude of that? And once again, we use c squared equals a squared plus b squared. A is, let's say, let's call this A and this B. So we're going to have 9 meters per second squared plus 16 meters per second, and all that is squared. This is going to be 81 meters per meter squared second squared plus, gotta do a little math over here, 16, 6, 3, 696, and that's going to be 6, 1, 256 plus 256 meters squared second squared. If you add that all together, you end up with 7, 33, rid of that. We'll go on to the next page because I'm running out of room. And your answer is going to be, if you find the result of all that, you're going to end up with an answer of 18 meters per second. And we actually came up with that was pretty close to what we came up with our answer, is that path. So if the river is 136 meters wide, how long does it take the motorboat to reach the other side? Well, we know that our velocity is 18 meters per second, and we know that it's 136 meters wide. So from there, we'll use velocity equals distance over time, which is an equation we'll go over in the future. We put in velocity equal to 18 meters per second. Our distance is 136. We're plugging that in for D. V is equal to 18 meters per second. D is equal to 136 meters. T, we don't know, so that's what we're going to try to solve for. We put T underneath, and then we solve, and we end up with T equals 7.56 seconds. That's how long it would take to cross the river. Now we also use the trigonomic method to find this, and everybody starts groaning when they see this. This is sine, cosine, and tangent. So let's determine the components of a 20 meter displacement at 30 degrees northwest, and we need to find the A west component and the B north component. So if you look here, we have the a picture of our vector. It's 30 degrees northwest, and this is the northwest direction. It's 20 meters long from the point of origin to the arrowhead. If we go back here, we need to find the proper components for it. So our B component, what we're going to use is the cosine function, because we're trying to find, we know the 30-degree angle, and we're trying to find the adjacent side, which is the B side. So we're going to use cosine. Cosine 30 equals B divided by 20, and from there we can we can plug in 0.86 for the cosine. We solve by multiplying that by 20 to get b, and we end up with 17.2 meters for the b component. On the other side, we're here to find the a component, the horizontal component. We would use the sine function because that side is opposite the angle. So we would use sine 30 is 0.5 times 20 equals a, and we end up with 10 meters. So just a summary, when we add two vectors, we need to use, we can use two methods. One's a graphical method, which will really show us how long the vector is and also what direction is, and then the analytical method will also give us the magnitude, a squared plus b squared equals c squared. And we also need to use angular measurements, sine, cosine, tangent functions from trigonometry, and you might remember that as so sine opposite hypotenuse, cosine adjacent hypotenuse, and TOA, tangent opposite adjacent. And thank you.